Hi everyone, I'm Lee Gilmore, and today we're going to be looking at unlocking serverless superpowers, mastering the 8 crucial design patterns every engineer should know. So let's start with a very quick introduction. So hi, I'm Lee Gilmore, I'm a serverless advocate. I'm a content producer, technical writer, and AWS community builder. I'm based in the northeast of England and currently working as a global enterprise serverless architect globally. Now you can see there I'm on many channels, YouTube, Twitter, which is now X, Medium, LinkedIn, Instagram, and others. So if you want to get to me, have a look at that link tree URL, and that'll take you to a page which has links to all of these. So we're going to be covering today how can we master and compose the 8 crucial serverless design patterns to build any system. I will caveat that it's almost any system, but these are the 8 go-to patterns I think most people should learn. So we're going to be looking at the simple service pattern, storage first, API proxy, event gateway, call me maybe, change data capture, outbox, and Saga patterns. And what we look at the very end is how we can compose these together. So we look at 3 basic examples. So let's start with the first one, which is the simple service pattern. Now, for me, this will make up 80 to 90% of serverless solutions. So this would be your go-to. And this is very much synchronous request and response. And this is where most teams actually start out. And this pattern scales very, very well with high concurrency. So if we have a quick look here, we've got a user making a request to API gateway. We have a Lambda function that's doing the compute aspects of the business logic, and that's calling directly to DynamoDB. So that's where we're storing and retrieving that data. So I won't delve on this too much because it's such a simple pattern, but it's super simple to code. It's rinse and repeat. If you follow me, I wrote an article recently on Plop. So you can create a CLI using this tool, which will auto-generate a lot of this code for you. And it's going to cover most scenarios that you'll hit as an engineer. The only disadvantage is if you find that Lambda function is simply glue code between API Gateway and DynamoDB, then just remove it altogether. If there's no business logic, no transformation, just remove it. So next, we're going to look at the storage first pattern. This is one of my favorite ones along with the event gateway pattern. So storage first pattern, this is where we persist the requests as soon as possible, and that increases resilience and durability. So in the previous example, if we had a bug with that Lambda, say, we've lost that request. We return a 400, say, a bad request to the customer, and they then have to remake that request with a different payload. Whereas what we're saying here is we're going to store that request as soon as we can, so we don't lose it. We've got the original request data for resilience. So if we have a quick look at this pattern, we've got a user making a request to the API gateway. We've got a direct integration with SQS where we persist and store the payload. And what we return to the customer is a 202, so an accepted. And then at our own rate, we can then use a Lambda function or some kind of compute to pull from the queue and actually process those requests. So as you can imagine, this scales very, very well because API Gateway and SQS is just going to scale out massively, very, very quickly. So we're not thinking about Lambda, concurrency, and compute at this stage. Now, to note, obviously, it's not just SQS. We could use EventBridge, Kinesis data streams. We could have S3 buckets, DynamoDB tables. So that storage first could go directly to a plethora of different AWS services using this pattern. So advantages, we've covered a lot of these, but the benefits for mission critical systems where we want to persist that data straight away. It scales very well. Like we said, the storage first service will scale out massively, and you're very rarely going to lose that request. Now, one thing to note is that direct integration, we have less chance of bugs or configuration issues. So again, if you follow me, I wrote an article recently on end-to-end testing serverless solutions. So between API Gateway and that storage first service, say SQS, if you do end-to-end tests as part of your pipeline and you're checking for permissions and configuration issues, you're 100% sure when that goes to production that it's going to work, so you're not going to lose those requests. The only disadvantages really is there can be additional latency there from the compute aspect. That'll probably be mitigated by the direct integration at the very start, so that's probably not going to be an issue. But the other thing to note is with the synchronous model that we talked about, the customer makes the request and they get the response instantly. So if there's a problem with the payload, they can make that request again based on the error that comes back. Now here what we're doing is just returning a 202 and accepted. We've accepted that request. So if it's a particular scenario where you would need the customer to actually amend that data to then fully process it, say it's gone to DLQ, then that's not going to work very well, because if it's a web app, for example, that customer might have browsed to another page or might have closed down the browser altogether. So it has to be a design consideration. So now let's look at the API proxy pattern. So this is where we create a front door that proxies the downstream systems. Again, if you follow me, I'm very big on cell architectures or serverless architecture layers. And this is where you have your domain services private to the AWS network downstream. These are domain services. And then we've got the notion of experience layers. So we have what could be a BFF, a backend for front end to a web app. It could be an IoT device. It could be an API for B2B, so machine-to-machine flows. So this is where the API proxy pattern comes in. So if we have a quick look at this, we've got the API proxy part at the very start. So we've got API gateway to Lambda here. And we are just exposing the functionality that we need to for these downstream systems. So the order service and the stock service might have a plethora of different resources and methods available. But within this particular proxy, we only want to say expose, create order, and check stock, so get on stock. So again, this API proxy is synonymous with that particular use case. So here we've got users, but this could be machine-to-machine flow here, client credential grant flow. We could add caching, again, that's synonymous with this particular use case, whereas users might be an implicit flow and might have a different authorization model. So a very powerful way of doing this. So advantages, we've got one entry point for external customers. I guess if we didn't have this API proxy, what we'd have is that web app or that consumer API would then need to essentially be multiple downstream APIs. So they would have to consume all of these, say, 20 domain service APIs. But this proxy in place allows them just to interact with that one API. We can have orchestration in here, so we can use step functions, which we'll talk about the orchestration in Saga patterns later. We can add a level of caching in here in this proxy layer, and that caching, like I say, could be synonymous with that particular use case, the person that's actually using that channel within the experience layer. And we can have our own authentication and authorization flows, like I say, depending on what that use case is. One of the main disadvantages I think we need to think about is ownership. Now, I've seen in the past, because this is horizontal across many, many different vertical domain services, that many teams are in that code base. So everybody owns this particular API, so nobody does. And that's what you sometimes find. And if we look at team topologies, we want this to be a stream-aligned team that looks after this. And where we can, we want to limit handoffs and dependencies between teams. You obviously may experience additional latency having that Lambda function in there, is that proxy. But again, if you look at cell architectures and if you're using SIGV4 and IAM, then this is negligible. It's very, very small. So next, let's look at the event gateway pattern. Like I say, this is one of my favorite ones. And what this is about is allowing third-party applications, COTS products, legacy applications within your overall ecosystem to actually raise domain events. And we do this by putting an API in front of our central ESB. So again, I'm very big on the single bus multi-account pattern when it comes to Amazon Event Bridge. And this is what we're doing. We're putting an API in front of this ESB. So let's have a quick look at this pattern. So here we've got a third-party application that's hitting this API gateway. And as long as it can make a HTTPS request, it can publish domain events. So very powerful. So this API is a proxy directly to Amazon Event Bridge. And the API is going to have basic request validation to check that the event, again, I'm quite particular about this, but the event has metadata properties, so the source of the event and the event name, but also the data properties. So event carried state transfer, we want that full fat event payload on there. But the real power comes in is that we've now got these downstream AWS services that can listen and consume these domain events coming from this legacy application and then do processing off the back of it. So advantages. So this ultimately allows legacy or third-party applications to be part of our ecosystem and start raising and publishing domain events to our central event bus. And this can be very powerful when we combine it with CDC, transactional outbox, and webhook patterns, which webhook we'll talk about in the next section. And obviously we can add authentication and authorization to that API gateway. We could add WAF, Shield. We can add all of the security controls that we want around that. And one of the advantages is the third-party systems or legacy applications can be written in any language as long as they can make an HTTPS request. So disadvantages, we talked about the basic request validation. Now we can get around that by having a Lambda in the mix as a proxy in there. And that Lambda is going to pull down the right JSON schema based on the event name and the source. And that allows us to do fine-grained validation at that point if we need it. So the second part of this pattern is the call me maybe pattern. So I talked about webhooks, and that's what it's often referred to in the industry. But when I use it with Amazon Event Bridge API destinations, I call it the call me maybe pattern. So based on an event, we might call this HTTPS endpoint. So how it works is the first part of this was all about third-party applications and legacy applications actually publishing their own domain events, the Event Bridge bus. This is about these systems actually consuming these published domain events from other systems, obviously including AWS systems. So let's have a look how this works. So we've got an AWS service here, and we've got API gateway to Lambda. That Lambda is publishing an event to our central event bus. And then we have a target rule, which is an API destination, which goes directly to this third-party application. So now what we're doing is allowing them to consume, as long as they've got a REST interface at the front of their third-party application, they can now consume these domain events. So as we say, this is very powerful. It's two-way asynchronous communication, and we're now bringing in any third-party products into our AWS ecosystem. One thing with API destinations is it automatically handles the retries and exponential backoffs, which is great. But with any AWS service, we want to take away a lot of that heavy lifting where we can. And it also has the use of connections. So authentication is handled seamlessly. So they have IAM authentication, auth to basic auth flows, API keys, pretty much any authentication method that you're going to need. One disadvantage is cell architectures. Again, we talk about private API gateways for these domain services. One problem with API destinations is it only works with public endpoints. So even if you put an internal ALB in front of that private API gateway, it still doesn't work. And this is something I've spoke to the EventBridge team about, and it's on their radar. So hopefully in the future, this will be remedied. Okay, so let's look at the CDC pattern next. So this is all about reacting to data store changes in real time. So what we might want to do off the back of some data being changed or persisted in the database is actually raising an event. Could be sending an email or doing some kind of processing off the back of it. So if we look at the change data capture pattern, we've got, again, API gateway, let's go with order created. So they're creating this order, and in DynamoDB, we're persisting that order record. The CDC part comes in, the change data capture is DynamoDB streams. So we're actually looking at the changes, which could be a creation, a modification, or deletion of that data, and we're streaming it to somewhere. So in this instance, it's a Lambda function. So the advantages is CDC enables real-time or near real-time data processing by capturing data changes as they happen. And this naturally fits into event-driven architectures where we can publish events or do some kind of notification on the back of a change, off the back of an event. And a disadvantage, I wouldn't say it's a disadvantage, but just a design consideration is this is all asynchronous in nature, which is something we need to work through. Now, the second part of the CDC pattern is the transactional outbox pattern. And in the previous example, if that Lambda function had had a problem, say there was a bug introduced, then that notification, that sending of an email, or the publishing of the event would never happen. So what we want to do is make sure that other downstream systems always get that notification or that domain event being published so they can consume it. So this is all about reliability here, making sure that downstream systems get these domain events. So if we look at how that works, the CDC part is exactly how it was before, API gateway, storing records directly in DynamoDB. The CDC part is DynamoDB streams. But now what we've done, we've introduced Amazon EventBridge pipes, and we're piping these data changes to an outbox. Now, that could be many different services, a bit like Storage First. It could be SQS, could be EventBridge. But the key part here is we're persisting these domain events, so we're not going to lose them. Because what we don't want happening, if we go back to the previous scenario, is data being updated in DynamoDB, we stream these domain events, but they never get published because of a bug. So that's what the transactional outbox or the outbox pattern remedies. Now, this pattern's been around way before serverless. So what we can do is actually use this with our legacy applications if we're doing some kind of modernization. So in this example here, we've got a legacy application right into its own data store. We introduce triggers off the back of this. That's the CDC part, and we write to another table, and that table is the outbox. And then what we can have is a processor. So it could be a .NET service or Java service that's then reading the outbox. So we will never lose these domain events. And we can then hit an HTTPS endpoint, which in this instance is a new serverless function. So some kind of new functionality in the cloud. But as you can imagine, if we then look at the event gateway pattern and the call me maybe pattern, what we could do is start strangling out functionality from these legacy systems. So that outbox processor calls the event gateway to say this domain event's happened. Downstream systems or other third-party products, for example, can then do some kind of processing. They can then, off the back of that, raise their own domain events using API destinations to call back to the legacy system. So we can start strangling out that functionality into the cloud over time. So we've talked about most of these, but the advantage mainly is these updates are always going to succeed and we can handle failures gracefully. That is one of the key things. We always want to make sure eventually we publish these domain events. Disadvantages for diehard DDD fans, they might think that the aggregate itself should be within a database transaction right into the outbox table and the master data at the same time, as opposed to using AWS serverless services. So that's one to discuss with your team, obviously. So the last pattern we're going to look at before we look at composing these is the Saga pattern. So this is managing distributed transactions using Saga patterns. And it comes in two flavors, one of which is choreography, and it's all about using domain events. So again, Amazon Event Bridge, and that triggers local transactions in other domains. So you're doing choreography, a distributed transaction, some kind of flow across many different domain services based on events. And the other one is orchestration, and this happens within a bounded context, and this is more of a workflow, say. So let's start with choreography, the event-based example. So this is very decoupled, as you can imagine. It's all based on events. So if we look here in the example, we've got the order service, and off that Lambda function, we publish an order created event. So it's in a draft status at that point. That goes to the central event bus. Then we've got a customer service that goes, we've had an order created. So what I'm going to do is I'm going to validate that customer. I'm going to have a look if they've got credits. I'm either going to, off the back of this domain logic, I'm going to raise one of two domain events. One could be customer credit verified, and one could be customer credit denied. That obviously goes to the central event bus, and the order service can now consume that domain event. And off the back of that, it could either complete the order or it could cancel the order. So you can see here, this is a very basic distributed transaction, and this can obviously get very complex over time, the more domain services you pull into this transaction. So the next one is orchestration. So you can see on the right there, this is more workflow based, and this should always happen within a single bounded context. And this is using step functions. So we can see here, again, it's very similar to the previous one. Somebody creates an order. We've got a direct integration with an express workflow here. We place the order, so we put it in DynamoDB with a draft status. We then invoke another function which checks the customer credit. Now you'll see here, one of the key things is it's working with a materialized view. So its own customer data, it's built up based on customer domain events. So it's not calling out and coupling by going directly to the customer service. So this is all within that bounded context still. It then checks, is the customer valid? If it is, it'll complete the order and update the database, or it'll cancel the order and update. And one of the key things is we should always be raising events regardless of its orchestration. So we can see here, we've got an order completed event going to the central event bus. So now let's look at the choreography and event-based advantages and disadvantages. So this is the most decoupled way of creating distributed transactions across domains. And this is obviously across many different bounded contexts. But what we can do is we can actually link this up with the two patterns in combination. So we can have the choreography, the event-based distributed transaction across multiple different domains, but each of those domains can use orchestration within them. So again, a very powerful approach. So the disadvantages, this can become fairly complex to organize across many different domains and therefore teams. It's obviously harder to debug and visualize because with this, it's all completely asynchronous based on events. And if there's a bug introduced, it can be quite difficult looking at logs at what's actually happened there. So the next one is the orchestration, so workflow based. So again, the advantage is it's explicitly controlling the flow of the transaction. It's clear and well defined. We can go in the console. We can actually look at that workflow. We can look at previous runs. We can look at the inputs and outputs of the state in between these different steps of the workflow. So it provides really good visibility of that transaction. Disadvantages, obviously, we don't want this to work across all different domains. We don't want to couple these domains, so the orchestration happens within one bounded context. Except if we have an experience layer, so a BFF, for example, you might want to have some kind of orchestration there across multiple downstream systems, a bit like the API proxy. But that's pushed right out to the actual user, the customer at that point. It's not happening within the domain services. So how can we compose the 8 patterns together to cover any use case? So let's have a look at 3 different patterns very quickly. So the first one is communication with legacy or third-party systems. So the call me maybe pattern and event gateway pattern. So we talked about this a little bit earlier. So we've got an order domain service, and this is using the call me maybe pattern. So we might have an order created event. The target rule then uses API destinations to call this customer domain service. And then off the back of that, that customer domain service can do its own business logic and raise its own domain event by using the event gateway pattern and publishing that back to our central event bus and then other systems can consume this. So in this example, the order domain service actually consumes that itself. So the next one we look at is the workflow based on critical request payload. So this one is storage first pattern plus the Saga orchestration pattern. So we're looking at a payslip domain service on the right here. So let's say we've got a desktop application and it's publishing payslips for employees. So JSON objects that are very large with payslip and employee data. We want to persist this straight away. We don't want to lose it. So it goes directly to SQS. And we then use Amazon Event Bridge pipes to do an async invocation of a workflow. And we can see here, this is where the Saga orchestration pattern comes in, where we validate the payslip and we save it to DynamoDB. We then generate the payslip. So we might generate a PDF and store that in S3, for example. And then we publish the payslip. So we send an email and we also raise and publish the correct events. So the payslip published in this example for downstream systems to do something with. And let's look at one more. So we talked about experience layers. So this one is an experience layer BFF where downstream services raise events. So this is API proxy with simple service, with CDC, with outbox patterns. So from an experience layer perspective, we can see that we've got a Vue.js app and it has its own BFF. Now that BFF, that backend for front-end API is GraphQL in this instance. And it is a simple service in its own right. So it has its own data that it stores. And we've got DynamoDB there in the mix and Lambda. But it might also have a Lambda resolver that talks to downstream systems. So it could be creating an order. So we've got this order domain service, which is private. That's in the domain layer. And this in itself is a simple service, API gateway to Lambda to DynamoDB. We've got CDC in the mix with DynamoDB streams. And then we've got Amazon Event Bridge pipes talking to SQS. So we've got that outbox pattern. So we're not going to lose those domain events. And we've got a Lambda then publishing off the back of that. So again, you can extrapolate these patterns out and build whatever you need to with these 8 crucial design patterns. So I hope you enjoyed that. I've wrote a very detailed article on this, which you can obviously go and read, and it goes into a lot more depth into these different patterns. And what I will be doing in a second article, second part, or part 2, is actually writing the code for these particular patterns. This will be a GitHub repo written in TypeScript and CDK, so you can pull that down and actually have a play around with it. And to actually read that, go to blog.serverlessadvocate.com. Thanks for listening, everyone.